This is the revision exercise 10A on heat and thermal energy. Number 1. The specific heat of iron is about 3.4 times that of the gold. So specific heat of gold. Now both of them have the same mass at 20 degrees Celsius. Now if you look at this is iron and this is gold, both at 20 degrees. Now you have put the same amount of water, which is at 40 degrees Celsius. Now for the iron, if there's an energy flow from here to here, from the water to iron, in order to rise 1 degree, and the amount of energy here from water to iron is 3.4 times that of amount of energy from water to gold. It means for the same amount of energy to transfer from water to iron, this amount of energy will rise the temperature of gold 3.4 degree instead. So eventually the both the iron and the water in one side, they will reach equilibrium, and same as the gold and the water, they also reach equilibrium, but the equilibrium temperature of a gold and water will be higher than water and iron. So the answer is B. Number 2. Now they are in thermal contact, so it doesn't matter the specific heat, as long as the two pieces of metals, they are in thermal contact. The amount of, it doesn't matter which one is higher temperature, which one's lower temperature. All we know is if there's a heat flow from one piece, from one metal to the other, from one material to the other material, either from aluminum to copper or from copper to aluminum, we'll see they both have the same size of gain or lose heat flow. So the answer is C. Number 3. Temperature of land rises more quicker than that of the sea because the specific heat of the soil is less than water. The answer is B. Number 4. If you want to know how much the temperature of a particular piece of material would rise, so when a known amount of heat was hit to it, which one you need? You want to use specific heat. Number 5. It's well known that water has a higher specific heat than iron. Now consider equal mass of water and iron that initially in thermal equilibrium. Okay, so it means now the equal mass of water and iron. They're in thermal equilibrium. It means they have the same temperature. Same amount of heat flow add to each. Now, of course, you put same amount of heat, but because the specific heat, I mean the delta T is equal to Q over mc, you have the same mass. If you same amount of Q, specific heat higher, the change of temperature will be lower. So they will no longer in thermal equilibrium. Yep, because one will be higher, one is lower. But the iron will be warmer because for the same amount of heat, the rise of temperature of iron will be higher. So it means the temperature of iron will reach higher than the temperature of water. So the answer is B. Number 6, a piece of metal absorbed 1,600 joule of heat, rising its temperature by 12 degrees, and you got the mass. So you just use the definition of specific heat, delta Q mc delta T. Specific heat, delta Q over m delta T. Plug the number in, you got the answer is number 6. Yep, the answer should be C. Number 7. Now, if a student poured 2 kilograms of water into the aluminum saucepan of the mass, which have a mass of 2 kilograms, what's the total heat capacity of the saucepan and the water? Now, the total heat capacity is the heat capacity of the water plus heat capacity of the saucepan aluminum. Now the heat capacity is equal to the mass multiplied specific heat. So this is your water plus this is your aluminum. Therefore, water is 2 kilograms. Specific heat is 4200. Now, sometimes you will see people use 4186. So you look at the problem, it doesn't matter. So very close. 2 kilograms of aluminum saucepan. This is the specific heat of aluminum. This is your total heat capacity. So the answer is D. Number 8. So the rise of temperature. So you got this is your delta T. You got the mass. You got your specific heat of the iron. So this is your answer. So your answer is A. Number 9. Again, this is a simple calculation time. You got this mass of water using this power with perfect efficiency. How long will it take to rise the temperature from here to here? So you're putting in power. So the total energy required you put in delta Q is your power multiplied T. This temperature, this energy flow will causes the rise of the temperature. So the same amount of energy flow into it is equal to mass specific heat delta T. So your equation setup will be power multiplied T, the total energy input, equal to mc delta T. So your time required is mc delta T over power. So therefore you got 0.1144186, 10 degree difference, and this is 67. So your answer is 21 seconds. Answer is A. Number 10. When you transfer thermal energy by heating to a substance, you always increase. When you increase its temperature. Now, heat capacity depends on the mass. So for the specific piece of substance, so it won't increase its heat capacity. Same specific heat is material dependence. Now, temperature. Now be careful. When you transfer heat into a substance, there will be a time, say during the phase change, the temperature will remain unchanged. So it means temperature can change, but in some circumstances, it could remain unchanged. What is always change? What is always increase is its energy. So the answer is D. Number 11. The heat required to change a substance from the solid to the liquid state is referred to heat of fusion. Number 12. We have to look at this diagram. There's a two substance, P and Q, and you can see there's a time and the temperature remains unchanged. Okay, so it means there's a phase change. So for the Q, the phase change temperature is here. For the P, this is where the temperature, there's a phase change. Now let's look at one. We have to look at all these statements one by one and determine whether they are true or false. Number 1. Solid P absorbs more energy than solid Q before changing of state. So solid P. Now remember, this is the time. So you are the two heaters supply the heat. So you can say this is a resistance here. So you can look at the power. The power the same. So the total energy is power times T. So because they at the same rate heat. So the same power, same time, P and Q actually absorbed same amount of energy. But you see, from here to here, P, the temperature rise of P is more than Q. Why? Because same amount of energy, look at here, same amount of energy, delta Q or E whatever, M, same mass, C delta T. If the specific heat is different, the less specific heat, the more change in temperature. So it means the specific heat of P will be less than the specific heat of Q. So same amount of energy, it will rise the temperature more. But in terms of here, solid P absorb more energy than solid Q before changing its force. They absorb same amount of energy. Solid P has a greater specific heat. It's another way around. Actually, as we just look at it, solid P has a less specific heat than solid Q. So this is false. Solid P has a higher melting point. Yes, here is the melting point is definitely higher than Q. So this is true. So the answer is C only. Number 13. The answer is C. Number 14. When the vapor condenses to a liquid, so it means this is vapor. When it go into liquid, it will give off internal energy. All right. So it means during the condensation, there will be energy given out because the separation of gas or vapor is more than the separation between the atom. So therefore, you will give off its internal energy. Answer is D. Number 15. When a substance is at its triple point, it means may be in any or all of these phases. So the answer is D. That's what the definition of triple point. Number 16. As heat flows into a substance, its temperature changes according to the graph. So there's a substance, it change. For what section of the graph is the substance undergoing a phase change? Of course, BC, DE, there are two phases change. So the answer is BC, DE, B. Number 17. The graph shows the change in temperature as heat is supplied to a certain mass of ice initially at minus 18 degrees. What is the mass? So we can look at from here to here how much heat. Now during this time, the water or H2O change from solid to liquid. So this is here and this is here. So in terms of heat change, this is 12, this is 4. 12 minus 4, it means 8 kilojoule. So this is amount of heat it absorbs. During this time is ml heat of fusion. You want to know how much mass, so M equal to Q over latent heat of fusion. So this is 8 kilo joule over 3.3 times 10 to the power 3 joule per kilogram. Again, if you look at the unit, it will give you kilogram. And your answer is D. Number 18. This is your mass you have, and total melting. So at 0 degree, so there's a sum, it So all you need is using this number, heat of fusion, and there's a mass, heat of fusion. This is amount of heat required to melt the whole ice, and this is equal to B. Number 19. Okay. If first the phase change and then the temperature reduce. So during this time, now during the this is 0 degree, this is minus 36 degree. So there's an amount of energy required. How much this one? This is M, latent heat of fusion, and the temperature here change is, you're talking about this part, of course. The delta T is minus 36 degree. So you are in ice. So the Q in this part is M C delta T. You know the mass. This one is the specific heat of ice. Remember, it already turned into ice. So your total heat required or liberate is M. This one is from the phase change plus MC delta T. So you plug the number in, and remember, this is the specific heat of ice. So this is your answer. Your answer is A. Number 20. This is the same argument. This time you have a copper, put a melt, so you melt again. Okay, so first of all, the initial temperature is at 300 K, so it rises until it melts. Okay, so there's a two part. First is the energy required from 300 K into its melting point, which is 1357 K. At melting point, you still have to supply a lot of energy to melt the copper. So two parts. One is MC delta T plus M heat of, this time is heat of vaporization. Actually, heat of fusion. Yep. So all you need is use these terms, plug the number in. The common term is mass, and then you plug this specific heat of your copper, change of temperature. This is for, this part is for the rise from 300 to 1357, and this part is for melting. So this is the number here. So your answer is C. Number 21. Okay, the same argument. You got the heater here. The heater, the power, you know, is P. So PT, this is your delta Q. I mean the energy you put into the water. And this must equal to MC delta T. So therefore the T is equal to MC delta T over P. So M is 0.1144186. The change of temperature is 10 degree. Where's the power? The power is 67. So that's your answer. You will get is A. 71 seconds.